I'm part of the Globus team. I co-lead the research arm of the Globus team. So generally I don't do tutorials, but I use the APIs a lot, so hopefully we'll be able to get through this. So I want this to be completely interactive. I don't know what your interests are in terms of Globus. I know that Blue Waters is one of the biggest Globus users there is in terms of data usage, in terms of users. So I expect many of you have at least come across Globus in your research activities, your daily activities, so we can take this wherever is of most interest to you. So I'm going to specifically talk about how you can exploit the Globus platform, the APIs, the Globus SDK to programmatically invoke Globus operations, move data around, share data. We can talk about other new capabilities, search, data publication if you want to. I can take this wherever we want to go. Before I start, so there's a couple of, I think, quite useful links. The first is to all our public SDKs, example codes, services, etc., that you can download and play with yourself. The second is our documentation page, which has sort of hands-on tutorial information to help people use the APIs and SDK, etc. So I thought I'd briefly level set with what Globus is. So I think most of you are at least familiar with the software as a service side of Globus, which provides a nice web interface. You can go in and manage your data irrespective of where it might live. Globus is also a platform for building applications, science gateways, web apps, etc. So you can build upon the sort of fabric that we've created over the last 7 years, hopefully avoiding the need to manage authentication, authorization, manage access to data, manage things like discovery of data, etc., and build sort of value-added services on top of the platform. So really that common cloud story. In terms of interfaces, again, you're probably all very familiar with the first one, the web application interface that provides what I think is a relatively seamless user experience to move data around, very large amounts of data. We also have a CLI. The CLI has recently been updated, but previously it was an SSH-based CLI where I had to SSH to actually run commands. Now it's a pure CLI you can install on your machine and basically command line invoke various Globus actions. And then the final one is the REST API. And everything is essentially built on this REST API, the web interface, the CLI, the Python SDK, which I'll talk about in a few moments. In terms of what services we provide, so this is a little picture here showing the APIs, the transfer API on the left, the Globus auth API sort of underlying everything, some general capabilities in the middle around file transfer synchronization, replication, file sharing, data publication and discovery. And we have this Globus Connect software that is deployed on places like Blue Waters, on laptops, on clouds and supercomputers that allows you to basically connect your storage systems to the Globus ecosystem. So the thing I thought I'd probably focus on is the transfer API. I'm assuming that's what most of you are interested in using. Please correct me if that's not what you're interested in. We can wing this, but I think that's what I was asked to talk about. So the transfer API is a basic JSON-based REST API where you can pretty much invoke any operation you can perform through the website. So the web app, as I say, is built entirely on this transfer API. We have extensive documentation of the API on the docs page. One thing I normally do if I'm trying to work out how to use the APIs, I just go and copy the commands from a web browser. I go and pull up the developer tools and just copy the commands that are actually being called behind the scenes, and that tends to get you what you need pretty quickly. All of our APIs are secured with OAuth 2 tokens. So basically when I'm making a call to one of our REST APIs, I'm passing in JSON, I'm receiving JSON, I'm also needing to pass in a bearer token that allows me to access whatever capabilities are permitted to my user. As I mentioned down the bottom, documentation about the transfer API. On top of the REST API, we have this Python SDK. So REST APIs I think are great for web developers, but for the common person like myself, I find it much easier to work in a nice Python environment where I can tab complete things and I have sort of support for paging and dealing with the strange objects that are going to come back to me, the errors, etc. So the Python SDK has clients for various Globus services. The one we're talking about here, the transfer client. So essentially I can just import the Globus SDK, construct a transfer client, and go about my transferring or sharing or synchronization, data management in general. So what I thought I'd do is go through a walkthrough of an actual Jupyter notebook where we can play with some of these things. We can go as fast or as slow as people would like to go. How many people are familiar with Binder? People used Binder before? Okay, so Binder, I'll explain Binder then. Does anyone know what Binder is? No? So Binder is this really interesting web-based tool that essentially allows you to play a Git repository, a notebook that sits in a Git repository. So using Binder, I can point it at a Git repository. It'll create a container for me and give me an environment to actually run the notebooks that are in that Git repository. So it makes it nice for things like demos because we don't have to download the code, we don't have to run notebooks on our machine, which tends to lead to problems. If anyone wants to follow along, feel free to download notebooks. They're available in our GitHub repo, or spin up a Binder environment to try some of this stuff. So essentially, very simple interface. I basically plug in the GitHub repository that I want to use, which is the Globus Jupyter Notebooks. Click Launch, and behind the scenes, that should be on their resources, be firing up a container with all the dependencies for this notebook and populating it with the notebook that I want to go through. If this fails, we'll do it locally. Okay, so here we have this, the notebooks here, this Git repository that I just pointed it to. We have this SDK notebook that we can spin up. The Blue Waters nodes are actually, the DTNs are still running, so let's do this demo using Blue Waters. That's not the right one. I've got too many notebooks open. Okay. So I'm just going to enter here the ID of the Blue Waters endpoint, which you'll have access to, and also the path in Blue Waters in which I'm allowed to share data. You guys, I think it's a little bit different. I think there's a project/user, and then your account sharing environment. Okay. What's that, sorry? The actual ID here? You don't need to remember that. I'll show you in a minute how you can search for it. But if anyone wants to copy this down quickly, it's only, what is it, 32 characters or something? Yeah, so please don't remember that. I mean, the easiest thing to do is probably spin up the web interface, go and type in the endpoint you're looking for, and you can copy the ID of that endpoint. Okay, so that's just basic setup. I've just got some endpoints defined that I'm going to use for various things. I expect if everyone here is a Blue Waters user, you already have access to the Globus advanced capabilities around sharing. If you do not, just join this group. I think there's a link here, this tutorial users group. Must be up the top. Yeah, so just click on that link. Again, these notebooks, you can just spin it up in GitHub and click on this link, and that'll allow you to share data. Okay, so the first thing we're going to do is authenticate. See, we're going to struggle to fit this on the screen. We're going to authenticate with the Globus auth system so we can obtain our access tokens that we can present to perform transfer operations. So as I mentioned, all the Globus services are built upon this Globus auth fabric. It's a pretty general, completely open and free service that people can use to secure their REST APIs, allow services to speak to one another, and also to create various types of clients. In this case, we're going to use a native app, a Python application. You can also build service apps and other types of OAuth apps that you can securely authenticate to and authorize. So essentially what we're doing here is, I mean, I'm not here to talk about Globus auth, but we'll maybe talk about it a little bit. We have a client ID at the top, which is a registered client for this notebook that I'm showing. There's a page where you can go and register your apps. It's, I think it's developers.globus.org. Don't hold me to that one. We're then defining a native auth client, and we're basically telling it to start the flow, to ask the user to go and log in, to go and retrieve their access tokens to use the transfer service. So I'll just quickly run this. It'll give us a link, a one-time link that I can go in, authenticate. I'm already logged into Globus, so I skip that step. This is my Binder notebook. It's useful to name these things because if you want to go and retract your consents, it's helpful to have a name that's not ABC. It turns out that I have a lot of ABCs and I never know what I can delete and what I can't delete. That gives us, I'm going through this quickly, that basically gives us a one-time code that we can then place in the notebook to continue, to retrieve our access tokens for whatever services we asked for. So I guess if someone was really quick, they could go and steal my code and then do all sorts of things. Okay, what we're doing here is I've entered the code. We're then just doing basic standard OAuth workflow. So we're taking that code, giving it back to Globus, hopefully with some sort of security token so you guys couldn't steal my access code, and giving us back whatever access tokens we asked for. So in this case, we're only asking for an access token for the transfer service. Okay, so now we're all done. Let's see if we actually have constructed this transfer client, which you see here. We've constructed it using the tokens we got back. We'll make a call now. So we're using the transfer client. So everything in the transfer client and the Python SDK has help functionality. So if you do help on a function, it's going to return this nicely formatted large string that gives you not only sort of the REST API that it's calling, but information about the data types that go in and out, how you use it in Python code, etc. So this really helps you to build these applications without needing to go and read a ton of documentation somewhere else. In terms of using the client, essentially all of these REST resources are wrapped within some sort of Python function that you can call. So for instance, this first one we're trying to do here is to go and get the information about a particular endpoint. The response from one of these calls is a Python object that's structured the same way for every single call. So it includes things like the HTTP status. So you might want to check when you make a call, are you actually getting a 200 back, or are you getting some sort of error? Are you getting a 404 or something else, a 500? It'll tell you the content type, and then it includes a blob of JSON, which is the data. And that data piece is specific for each call. So you sort of need to understand how to handle the response from, say, a transfer request versus how to handle the response from tell me about all the endpoints I have access to. So we'll quickly run this one. It's going to show us information about tutorial endpoint 1. So you see here we've got a 200 back. It was successful. The response is JSON, as everything will be. And then some data about that endpoint. So here we can see what the host name is, grid FTP information, other bunch of junk that probably is very unimportant to most of you. So there's a lot of information there. And of course, you can go and change this to the Blue Waters endpoint, which will probably look the same. So you're seeing back here. Of course, Blue Waters has a ton of different DTNs. So you'll see probably a long array of, I don't know how many DTNs you've got, but it would seem dozens. How many do you have? Who knows? 20 odd? 30 something, okay. Yeah, we should use this for hammering some machines. Okay. So as I mentioned before, one of the other advantages of using the Python SDK rather than sort of scripting this yourself is that we include a lot of functionality to make things easier. So in this example, things like paging. So we basically return iterators that we can just continue to go through a list of responses without needing to say REST API, query parameter, page 1 starting from result X. So here if we go through and say search for all my endpoints, it's going to join together probably several pages of endpoints. I don't know how many. I think I have more endpoints than that, so maybe I need to do something a little bit different to get more results back. So you see here, this is just the endpoint search command. I'm passing it in a scope where we have scopes, as you've probably seen on the website, things that you own, things that are shared with you, things that you've recently used. So the shortcuts, again, you can find in the help for the endpoint search. Of course, there are some endpoints that we don't yet have sort of wrappers for in the Python SDK. We don't stop you using those. We provide a sort of general get function where you can basically go out and call anything you can in the REST API, and you'll get back at least the shell of the standard response types, the HTTP codes, the content type, and the results. So I won't go into that because I think that's probably not so interesting. Errors, I mentioned this before. I think this is one of the advantages of the Python SDK is essentially we wrap all the errors and hopefully try and sanitize them to some degree, so you're not getting some opaque HTTP code, you're getting back some description of what the error is. So I'm assuming this must be an endpoint that doesn't exist. So here, again, you're seeing essentially you can catch it as you would in any Python script. We can see the status, we can see the code and the message that tells us this endpoint is not there. Okay, so I've got about 10 minutes left. So someone before mentioned how do we avoid having to type in a 32-character string? So essentially here we can use the endpoint search command to search for Blue Waters, and you'll see, I'm assuming this was the one I entered before, you'll get back the ID and other information about that endpoint. Let's move on to actually doing some data transfers because I don't think it's not very interesting to go through endpoint management. So the first thing, I think all of you have used Globus understand this concept of activating an endpoint, basically the authentication step to say I can use this endpoint. For endpoints that trust Globus, you can auto-activate them based on your access token. So for shared endpoints, for tutorial endpoints, for various other endpoints. For endpoints like Blue Waters, you actually have to go off and authenticate using my proxy, using auth. If you use the Python SDK, it's going to tell you what you need to do. The easiest thing to do is just follow the link and go off to Blue Waters to actually activate the endpoint. So given now we've activated these endpoints, let's Let's do my home directory on Blue Waters. Let's assume I didn't, okay. So here we're doing an ls operation, so we can see it in the, probably should have brought a pointer. You can see here the operation ls. I'm passing in the endpoint ID, which was the Blue Waters endpoint I defined above, and then the path that I want to look at, which is just my home directory. And I'm seeing a bunch of hidden files, a few directories, more hidden files, it turns out. I've got a lot of hidden files. And you can also traverse down, so you can list another directory or whatever. You can define a crawler, essentially, that's going to go through everything recursively. I can make a new directory if I want to. So in this case, I'm making a tutorial directory on, let's make it on Blue Waters. We'll make a new tutorial directory. You can, again, these operations are fairly commonly named, so it's operation underscore and generally the Linux command line name for what you'd want to do. You can also rename directories. We won't go into that. We'll go into task submission and management, so how we actually transfer data. So the way we construct a data transfer is basically this block of code here. We essentially pass it the source endpoint from which we want to transfer the data, the destination endpoint to which we want to transfer it, and then we define below here a set of items that we actually want to wrap into that transfer. So those items could be a set of files that you explicitly outline. It could also be a directory with the recursive flag set that's going to transfer all of it over there. We see here we've got the recursive flag. So let's transfer this to Blue Waters. Let's transfer it to Blue Waters tutorial. And let's do that. So when you submit a transfer, as you all know, it's an asynchronous operation. What you get back in return is an ID that you can use to go and introspect that transfer, go and find out the status, go and kill it if you want to, other types of management. So we've gone off and created that task. We can now go and find out information about it. Again here, obviously I transferred about 3 files and 14 bytes, so that happened very quickly. It tells me sort of general information about what I've done, where the transfer started, where it went to. It tells me some information about the transfer rate, again, limited because I moved a tiny amount of data. And then we can also go and check, has that data arrived? And so this is listing the contents of the Blue Waters directory that I transferred the data to. Okay, so we're still running a little bit short on time. A lot of other operations to check task lists, etc. So let's get down to the sharing part, because I think that's probably something you would actually use. So as I mentioned, I think all Blue Waters users have access to share data. Okay, there's a lot of stuff here. And the benefit of sharing data is essentially you can, without giving someone their own Blue Waters account, you can basically make a directory or a file or a set of files accessible to other people through Globus. So you can basically apply an access control list, a list of user IDs or group IDs that people can access. In Blue Waters' case, they can only read it. In other Globus sharing examples, you can also write. So you can create a directory that you can write to and share your data in that way. And I mean, this is one of the most useful things I think about Globus. I use this a lot with our students to share large amounts of data, file system dumps, lots of big traces of things. So it's very useful. So basic idea is very similar. Here we're going to create a directory, and then we're going to define how we want to share that directory. So we define here the host endpoint, the path on which we want to share. We give it a name, saying this is my tutorial shared endpoint. We give it a description, and let's create that. So we've created it. The endpoint is then given an ID, just like any other Globus endpoint. You can search for that ID. You can pass that link on to other people. So if we get information about it, this will just repeat what we just saw. It shows you that it was me that shared it, gave it a name. I have a lot of lists. And let's go down to how we actually go about sharing. So once we have a shared endpoint, that lives there until we delete it, and we can go and assign, as I mentioned, access control permissions essentially to any path within that shared endpoint. So essentially here I'm saying I want to provide an access permission. I want to give read-write access. I'm going to give it to an entire group of users, so anyone who's in the tutorial users group will be able to access this, and I'm going to give access from the root path within this endpoint. So if I do that, now everybody in the room will be able to read and write to that path on my shared endpoint. I'm pretty sure we have some tracking in place to stop you blowing that up, but it's probably best if you don't all transfer to it. You can get a list of access rules about the endpoint, delete access rules, update them, etc. So if you want to take something away, you can do that, and it'll happen instantly. So that's all I have in terms of the SDK. Does anyone have any questions? Anything I didn't show that anyone cared to see? No? So I'll finish up then. I'll go back to my slides and tell you a little bit more about... oh, I went back to the beginning. Okay, so a question we often get once we've got this, this SDK, people ask, how can I actually do this in my own Science Gateway, data portal, web application, etc.? So how do I take this SDK and build, say, a portal that allows people to come and discover data, to access it, to download it in various ways? So we have an example portal software written in, I believe, Flask, so it's Python-based. Essentially, you can take this example, it shows you how to stand up a search index with a web interface that people can come to, search for a data set, download it dynamically so we can reconstruct data sets. We can actually go off and create a graph based on the data that happens to live within the shared endpoint. And so it illustrates a lot of the capabilities that we talked about there. It shows you how you can really use the Globus SDK and Anger to combine lots of sort of data management pieces with authentication pieces. And it also serves as a good illustration of how the Globus auth system allows you to secure interactions between REST APIs. So the Modern Research Data Portal has not only the data serving piece, but it also has this separate reconstruction service that runs alongside it that allows you to reconstruct weather data into graphs and things. So I'd highly recommend, if people have interest in developing applications using the Globus APIs, to have a look at this code. There's a nice web page that includes a paper, documentation, examples of where this is actually being used, sort of in, I think, in 3 or 4 or 5 different deployments out there in the wild. So I thought I'd briefly mention the Globus auth service. So I didn't talk about this really at all, but it's quite a powerful service if you are going to be developing your own REST APIs or wanting to develop services that need to speak to each other, or client applications that need to speak to Globus services or other services that are secured with Globus auth. So, I mean, you can read the bullet points as well as I can. It provides basically a very simple but very powerful OAuth 2 based, so very standard implementation of an authorization authentication framework. So as I mentioned at the beginning, we have lots of support resources that are very open to people to use, documentation. We have a help desk that is quite phenomenal, so they're very responsive. We have a team that engages with customers, so people who are interested in using Globus in various ways come chat to our team and they'll be happy to talk you through what you need to do. And recently, I think about a year ago, we created this professional services team led by a fellow by the name of Rick Wagner. So they are open to interacting, working with people to build out prototypes, to build out solutions to problems you might have using Globus services and other sort of services in our cyber infrastructure-y world.